Hello, everyone. Today we're going to talk about how EDA is powering digital modernization of natural gas distribution. Today with me, I have the pleasure to introduce you to Stefano Passaro from Naturgy, the company Nedgia from the group Naturgy. He's going to be doing the presentation, and I'm Alessandro Canetti from Solas.
Okay, thanks, Alessandro. I'm part of the Naturgy IT team. Specifically, I work in the gas distribution company called Nedgia. Been around for more or less than 20 years working in the industry, and the last 2 years I was leading the S4HANA Greenfield implementation project from an IT point of view. And I'm really honored to have this opportunity to share our experience with all the Solas community. So something about Naturgy. We are present in the gas and electricity business in 20 countries and with more than 16 million customers. Our business is equally divided into regulated markets, which means transport, distribution, and maintenance of power grid and gas pipelines, and deregulated markets, so conventional generation, renewable energy, and retail. As a company, we firmly believe in the energy transition, and we hugely invest in wind, solar, and hydropower generation, and the use of biogases as a green alternative to traditional fossil fuels. Some numbers just to set the stage. We have more or less 5 million supply points, which are customers in electricity, and 11 million supply points in gas, and a huge gas network to maintain, almost 300,000 kilometers of electricity grid and gas pipelines, which means that if you took it and put it around the world, you could do it 7 times. So a lot of network to maintain. This was Naturgy as a whole. Now, Nedgia, the company I work in, is the first natural gas distribution company in Spain with 5.6 million customers, 6,000 kilometers of underground networks, and 400,000 assets that we have to manage, to maintain, and to enhance. And another nice number that we receive something like 300,000 calls per year that we attend in less than 10 seconds. Again, as Nedgia, as a gas company, we're full committed with energy transition. Our goal for 2050 is 100% renewable gas and carbon neutrality. Our approach about the energy transition is that there is no magic wand, as I really hope that you are well aware of. And despite the dogmatic approach about climate change of the last decade, now we are hopefully shifting towards a more pragmatic and feasible transition where biomethane and hydrogen have their own place to balance energy demand in Spain and in Europe as well. Okay, so let's talk something about our digital journey. In 2020, so almost 5 years ago, Nedgia started a journey to modernize our system landscape, to get rid of something like 10 old legacy systems and migrate to S4HANA. And in this journey, we literally discovered SAP BTP as the perfect platform to develop our integration. And inside SAP BTP, first the let's say vanilla version of Event Mesh, and then the advanced Event Mesh product. And the first contact that we had with Event Mesh was not strictly an integration case, because our previous experience with SAP was a 20 years old SAP system, highly customized, and so learning from the error of the past, we wanted to embrace this clean core approach, this philosophy of SAP to keep the core clean and extend the custom functionalities outside the core system. So the case was that we had to develop an application on top of the standard SAP, and we found the new capability of SAP to emit standard events through the event mesh, this component. And then we put a Node.js application to listen to these standard events, which is something that you can see in this slide picture. Pass data from SAP HANA core system into the HANA Cloud database. And on top of that, we put a front-end application to extend the standard functionality. So this, again, was our first approach to the event mesh. When we started using the event-driven architecture, we are talking about from 10 to 20,000 work orders per month that we were emitting in a first place. Okay, so we went on. We had this first event-driven use case. And as I said, we were in a journey to change our S/4HANA. And so we faced another, let's say, big issue that was integration. Because just as a quick reminder, we are the Spanish leader gas distribution company. That means we are basically an asset management company. And so we mainly do two things. We plan the development of the new grid, and we attend emergencies and corrective maintenance of the existing grid. So we have several triggers, so to speak, that cause what we call work orders operation, but we always have the same life cycle. That is, we create work orders that are planned, designed, executed, and closed in the same way. And this is important in our case because even if we manage the most part of our process in SAP S/4HANA, we need to interact with several systems like geographical systems, engineering systems that simulate the gas flow, licensing systems, SCADAs, and mobile systems, just to mention the most important of them. So for all this reason, even if the life cycle of our operation is mostly leveraged in SAP, we have more than 80 different interfaces with 15 non-SAP systems. And in the past, we did all of these integrations with MQ queues, the good old EBM product. So we treated it as batch integrations, periodic jobs, and so on, mainly because we had a very on-premise-based infrastructure. So before the S/4HANA project, we have the asset management processes scattered within some old SAP modules, some Java and .NET application in a very on-premise infrastructure. So huge file processing in our FTPs, file corporate system, batch processes, no online feedback, no web service, and bad data integration and quality. When we started the new project, we first say, okay, no more batch processes. We develop an API portal with a more open architecture. We'll start building REST API for everything. And we went on a strictly high cloud policy. As you can see in this picture, we have application in AWS, in the Oracle Cloud, in Azure, apart from the BTP SAP Cloud. But then in this journey, after the first go live, we started realizing that synchronous API was not always the answer, or was not only the answer. So we realized that actually our processes are quite consuming in terms of backend transactions, and that while REST APIs are good for retrieving quickly real-time data, we had some other use cases where we still needed real-time data, but maybe we didn't need synchronous communication. So, for example, let's take one process, the biogas activation request. This is a process where usually is involved a big customer that wants to produce biomethane from his plant and inject the biomethane into our grid. So it has to request a connection, and this request has gone through several steps, including engineering, permitting, interaction with local authorities, and then grid development, customer invoices, and all of these steps have to be managed and generated in the backend system. So to make the story short, we have here two mainly business requirements that require integration. We had to inform the customer in the public portal for every change in his request, and we wanted the customer to receive an instant invoice from the web portal. And this for our backend system means that we have to replicate, we have to create the customer in the corporate system, replicate into the SAP Asset Management system, then create the analytical figure in controlling, then create a sell order, then create an invoice, and finally print a PDF and send it back to the customer. So can you imagine doing this with a synchronous API and just to having the customer waiting all these backend processes? And so we entered again in the world of events. Our approach was to create several queues, one for the customer, one for the invoice, one for the PDF file, and to start publishing these events through the advanced event mesh channel. So while the portal is just publishing an asynchronous event with invoice data, it immediately closed the connection and just listen for invoices coming back from another topic. So the backend have all the time to process the invoice, do the rest of the SAP transactional stuff, and when has finished, it published to the same topic the result. So we have a totally decoupled process, asynchronous, but very near to real time. That we have more or less 2 or 3 seconds since the customer submit the invoice until he received the PDF file. And for the second requirement, which was to make the customer aware of every change in its request, we actually took the same approach. So we started publishing every change in the engineering phase from SAP, then the construction phase, then the permitting phase, and we said to the web portal, okay, just listen to these channels, listen to this topic, again in an asynchronous way, and change the status of the request depending on what the backend is communicating in every moment. So again, almost real-time communication with asynchronous queues instead of online REST APIs. And now, having successfully deployed this new website, we are seriously backtracking and reflecting on our integration landscape again. For example, for our mobile system for field activity, is it really necessary to integrate operations, work orders, as we do now with online APIs? We have published REST APIs from the backend, but we have to tell the mobile system to constantly ask for new operation. So we have a lot of API traffic with, of course, a huge system load, and in some cases, even loss of information. And actually, if a second system needs this operation, does it really make sense to deploy APIs for that second system and try to optimize the backend process in order to avoid the huge load of information? Or maybe it is easier to publish those operations once through a channel and make it available for every system that needs that specific entity. So we have launched several projects to transform, where it makes sense, the online synchronous API into events. So publish into several channels, and we expect to simplify our integration and have a more robust landscape. And then another very interesting feature where SAP and the Advanced Event Mesh broker are very powerful is that in the previous version of SAP, the standard event generation was very small in terms of the payload that was emitting. So we had to put a webhook listening to the queue and then make an API call back to SAP to retrieve the rest of the information that was needed to the application. Now, what we are seeing is that the new SAP version, the 2023, finally allows us to customize this payload. So another thing that we are thinking is to re-engineer our events to get rid of these API calls and really emitting at once all the data needed directly from SAP. And this means, of course, less code to write and less software to maintain. Okay, and when we thought that we could finally rest a little, a new big project came to us this year. Because it seems that this coming year, in 2025, the Spanish government will finally launch a project to change all the analogic counter meters to new digital counter meters. So it seems that in the next 5 years or so, we will have to visit all our 5.5 million customers, and we will completely change the meter reading process. Again, we are talking about something like 5 million readings per day that we have to upload into our backend, into our commercial system. And here, what we are seeing is that it is clearly another use case for event-driven architecture, where there is an IoT device that sends communication to an IT system that has to process heavy backend transactions like reading and invoicing. So again, here we don't see needs to synchronous APIs, and we prefer decoupled asynchronous communication. And apart from that, the other thing that is making us thinking about the event mesh is security, because for security reasons, we cannot let IT network communicate with the OT network, so the device network. And in this case, the SOLAS broker can come in handy, because what we will do is to install two different brokers, one in the IT side, coupled to the commercial system, and another into the OT side near the counter meter software, so that the OT and IT networks cannot communicate directly with each other, but the messages flows between brokers connected with a peer-to-peer exclusive connection, as the right part of this picture shows. And again, this is something that is we are launching next year, probably, and I will be more than happy to come back next year to tell you how this project has evolved. And so I think that now I can hand over back to Alessandro just to do some quick recap.
Perfect. Thank you very much. So we have reached the end of this session. I really want to thank Stefano for his presentation of the main challenges that Nedgia is addressing today in their modernization of their business process. And really, we could see the benefits that they have actually gained with the implementation of an event-driven architecture. So thank you all for attending this session. We will now take questions from the chat.